And this is the module and things that we will be dealing with in the coming Saturdays until the end of the semester, where we will start actually facing an exit exams, um, which will be administered actually at the various campuses. And let's work through what we have actually set up for today. So a few things about me. I'm Roderick Lottering. I'm currently at the Soshanguve campus. So I must have been a familiar face to some on campus. I've been at TUT for the last since 2017, and I've taught at various modules and things actually, and now using data structures and things. I'm currently PhD student also at the University of KZN. I've spent quite some time in books and things, as you can see there. I've done actually a Master in Computer Science at TUT. I've got a business leadership program. I've got a BTech, national diploma, and so forth and so forth. I like to do some research on student performance, and I've written a couple of conference papers on that, and one or two articles on that as well. Machine learning and deep learning, these are my areas of interest in terms of research, and there is my details for those who want to communicate with me. I'm, as I said, at the Soshanguve campus. There's my office number as well as my email address. I prefer email communication because with email communication and things, nothing gets lost. Most of the time, since this module is done online, I prefer that we do email communication and things, and therefore then actually that both me and you who wants to communicate with me will have an opportunity then to show that there's a record actually of the communication that we had actually. Right. So that's a bit about me. What we want to do today, we want to, before we do anything else, do some of these things. We want to have an introduction, which I've done already. We would like to select a class rep for the various campuses. And then actually we would like to maybe do some housekeeping rules and things as well. And although I have the objective here is introduction to data structures, I will stop at the introduction to Java, and next week we will carry on actually with data structures and get into the meat of this module. The reason why we focus on Java for now is that is actually what we as lecturers would prefer, but we also going to give students the opportunity directly to choose between Java, Python, and C++ in terms of implementing the various assignments and things that we will have. But when we do our classes and things, we will show you the code and the environments actually in Java. So I'm going to stop sharing my screen here, and let's just actually deal with the class reps first. This is going to be a very democratic, but quite an open process as well. So we would like to have a class rep per campus. And let's start maybe with the Soshanguve campus, because I am there. Maybe by showing of hands, those who are interested in that class rep for Soshanguve and things, maybe you can nominate yourself or you can nominate somebody. And I'm just going to have a little sheet here where I keep notes as well. We have actually, I'm not sure, is it a Mr. or Mrs. Ringo? You can unmute yourself.
It's Mr. N. Ringani.
Mr. N. Ringani.
Yes.
Right. I'm just going to make some notes. Right. Are you nominating yourself or are you nominating somebody?
Myself.
Right. Then we've got a second person. You can unmute yourself. Sorry, sometimes I have the ability or the bad habit of butchering your surname, and my surname is being butchered all the time. So don't feel bad if I butcher yours. It's just my payback time.
Not yet, sir.
Okay. Right. You know what I would like to do? Let's make it a bit interesting. When you speak, can you show us your face too? Because my face is going to be shown all the time. I would like to see you too.
Oh, okay. Let me just
Let people see who it is that we're talking to. We're not talking to a ghost.
let me open my camera. Oh, okay, yeah.
Thank you.
This is
Thank
me,
you.
yes. Yes.
You know, there are people that sometimes actually see you and they don't know you. That's why I'm doing that.
Oh, okay.
Thank you.
Yes.
Right, I've got Mr. Ringani. The next one, you can unmute, sir. The next person.
Good morning, sir.
Good morning.
How are you?
Very well, and you? Can you
I'm good.
unmute? Can you show us your face, please?
Okay, give me a second.
Okay. And I can see with this, actually, many people will not nominate themselves now because their face is appearing.
She's going to do some makeup.
Yeah, it's Uabona Ramanogu. I'm nominating myself.
Okay. Which campus are you?
Soshanguve.
All right. Okay. Any more people actually from Soshanguve? Thank you very much, ma'am. So we're going to start with the voting very soon. I just want to get all the candidates first, and then we go through a nomination. Anybody else from Soshanguve? Right, it seems like we only have the two. Right, Soshanguve, you put the option of selecting a miss or a missus, a mister or a miss. Right, that's here. Mr. Ringani, how many would like to see Mr. Ringani as your class rep?
I'm raising for just to ask a question actually.
Can we? Yeah.
Can they represent us, the two of them?
Both of them. We would like to
Yeah.
have one per campus, and the reason for that is otherwise we're going to have 6 people. And how much are we in this module? We are not so many in the module. I'm just
Okay.
looking. I'm just looking more from a administrative purpose point as well. So we've
Okay.
got around about 27 people currently. 28, 27.
Mr. Lottery.
Okay. Yes, sir.
So sorry to just jump in.
No
So
problem.
I think another thing we forgot to discuss is the gender balance. But as we select Atlas reps, we need to
Okay.
have a gender balance. Thanks.
Okay. So that means that we will need to have both.
I think so. Yeah. No, I think so. So yeah, I'm thinking now that if we were to select 3, then there wouldn't be much of gender balance. But it's something that we need to respect. As we submit the names, I think the department will raise that issue that we need at least a gender balance.
Right. No, I hear you, sir. Does the class oppose this? Let's just hear also. I like to have a very interactive class and just hear their views as well.
Do we raise our hands to oppose or not oppose?
No, you can unmute it and just let's make it as informal as possible, because
Yeah, I also agree that the gender balance is quite useful.
okay. So then I think for Shanguve, we will have the Mr. and Mrs. that came forward to select themselves. Can we move on to Emalasheni? Maybe let's see from Emalasheni's side. Who do we have actually?
Morning.
Good morning. When you nominate yourself or somebody, can I see your face too, please?
Yes.
Thank you.
Yes. So my name is Innocent. I'm nominating myself for Emanating Campus.
Okay. Innocent.
Yes.
Right. Anybody else from Emalasheni? Right. Is it the sir? Yes, sir.
Unfortunately, I don't have a camera connected to the PC I'm using right now, so I won't be able to show myself. But I wanted to nominate Andile Nkalanga from Emalasheni.
Andile, are you accepting this?
Yes, I am. Sharp.
Can you show your camera also, please? Or your face?
Also, I'm using a PC that doesn't have a camera, but I'm trying to also use my phone. It might take a while.
No. Let's it's fine. We can actually move over to Polokwane. I'm not discriminating against you, sir. I'm just looking at time as well, and I think we still have some other material and things that we need to work through as well. I hope you understand. Right, for Polokwane, let's have some nominations, please. Right, is that one hand actually for Polokwane? Right, sir, can you unmute yourself actually and show us your face as well? Good morning.
Morning.
Are you nominating yourself or somebody?
Yes, I'm nominating myself. I want to share my comments.
Okay.
Yeah, so I'm nominating myself. I'm Ezra Maran from Telogani campus.
Okay. Thank you, sir. We would like to have a female from Polokwane as well. Any nominations? Yes, ma'am, you can unmute yourself as well as show us your face, please.
Morning.
Morning.
I'm Julia Mutlauzi. Can I nominate him?
Can you nominate who?
Imaragane.
Right, that's fine.
Yeah.
We have his name. And how about the female class rep?
Can I nominate someone?
You can.
Sithole.
We already have
nominate,
yeah. Okay, Sithole.
yes, female.
Is she in the room and does she accept the nomination?
Good morning, sir. Yes, I do.
Good. Right. You can only, I am only convinced when I see your face.
Good morning, everyone.
Good morning. Right. I think that concludes the class reps for the various campuses and things. We will have for Soshanguve, Mr. Rengani, and Ms. Ramagunu. No, sorry. I am butchering it now. For Emalahleni, we've got Innocent and we've got Andile. For Polokwane, we've got actually Mr. Mahahane and Ms. Sithole. So right, ladies and gentlemen, that is our class reps. Can I just ask that these various class reps send me your detail, the email. Please, I would like to have your student number. I would like you to obviously going to give me your email address and maybe a cell phone number and things as well. So that when the various lecturers at the campuses and things need to communicate with you, they've got all those details of you with them handy as well. So can those that has been selected as the class reps just send me an email with all the detail and things as well. Thank you. So let's move forward now, and we're getting back into the agenda for the day. Let me just load my stuff again. Right, we've concluded the class reps, and we're moving forward now. So we have some general housekeeping rules that we need to talk about. First of all, this module is being offered at the various campuses, the 3 campuses. That is going to be the Soshanguve campus. We will have the Emalahleni campus, as well as the Polokwane campus and things. And we've got 3 different module coordinators at the various campuses and things as well. All the detail, email addresses, and all of that is in the study guide for you guys. And remember, guys, the study guide is basically the contract that you have between yourself as a student and the university And the various lecturers are just the representatives of the university. So we are the face of the university when it comes to this module. And when you're starting to interact in terms of things that you need to get done in this module, the first point of contact is your lecturer, the module coordinator at the various sites. Now, it's important to understand this because we also have when it comes to grievances and things, how the chain of command work is you have the lecturer and things that you interact with first. If you are not satisfied with the lecturer giving you feedback and interacting with you, and you feel that your plight has not been heard, you then take it up with the section head. Now, we just selected class reps as well. So if more than one student actually have an issue, you take it up with the class rep will then take it up with the various lecturers at the various campuses and things. And when you are not satisfied with the lecturer at the campus and things, I am playing the section head, the subject head role in this module, meaning that you can then interface with me if you're not satisfied with the response that you got from your on your campus. Then if I am not resolving your issue as eloquently as you wanted it to be done, you take it up with the section head. Section head will be is Mr. Masete, and I think his details is also in the study guide. And by the way, the study guide is already being published on Brightspace. Brightspace is going to be the learning management system that we use in this module for this semester. That basically means all the material that we will have will be made available on Brightspace. We will make the various classes, we will record them as well for those who might not have joined us, and it will be uploaded to Brightspace as well. All communication, that's basically announcements in terms of the link that we had to this module is already on Brightspace. Various announcements and things will be made on Brightspace as well, because that's going to be our main communication tool with you as the students. We also say that Brightspace will be used as the platform also to submit assignments. So assignments, we will have 4 assignments and things, and we will go through that as well. The learning material and things that we will have will be made available on Brightspace, and so forth and things. This module is an exam module. So at the end of the semester and things, an exam will be administered to you as well. The type of module we have is going to be both practical and theory that we will use. And the programming language that we will use in class mostly when we explain concepts and things will be Java. But when you respond to the assignments that are being administered to you, you have a choice between Java, Python, or C++. One of the 3. But we as lecturers, we will focus on Java when we explain the concepts and things to you. Yes, there are the various lab software and things, and these lab software is specifically for the labs and things that we will have in the various campuses and things, because what we're going to do is when you write your semester tests and your exams, it will be done in person with the labs. The assignments, we will use group assignments for this. And there's going to be 4 assignments. Let me just see if we are there yet already. We're not there yet. There's going to be 4 assignments, but a bit more about that coming. So we have actually these material things that we propose for this module, and we say that most of these material actually is available freely online, and since you are advanced diploma students and things, please note that we will not spoon feed you. So these are the material and things that we will use. It is upon you to go and find them. We're not going to provide them to you. Right. So these are, let me just make this a bit bigger. How do I do this? Right there. So there are the dates for the various assignments. As I said, okay, these are group assignments, and you will be assigned to a group. And yes, we know that sometimes actually students want to see each other, friends want to be in the same group and things. Unfortunately, you will not have that luxury in this module. You will be assigned to a group, and one of my rules is thou shalt not change thy group. And the reason why we do this, actually, you might think, but we don't understand and all of that. Actually, we do understand very clearly what we're doing. We are preparing you for the real world out there also, where you are going to be joining an organization one day. And in the world of work, we're working currently. You might work with somebody that's in a completely different city, a different province, even in a different country or a different time zone. And since we are computer science students, we're working in the ICT environment and things like that. There are tools that we use to bring us together, even if we have different time zones, in different spaces and things like that. There are tools, online tools, that we use to bring us together so that we can produce on a common goal. And that's basically the reason why we are proposing that you are going to be assigned to a group and not select your own group. There was a hand up, actually. Is it specifically with this, sir or ma'am?
Yes, sir. Yes, sir. Morning.
Morning.
Yes. I'm just inquiring about, is it gonna be group? Are you gonna be grouped for the rest of the semester, or based on an assignment?
Let's make it easy. Let's make it for the rest of the semester. And the reason why we do that is actually that normally with these who belongs to what group and things can be an administrative nightmare. And we want to make it easy both on you and on us. Because once you've met your team members and things, it just makes it easy. So what I'm proposing is that you will be assigned to a group, and we're going to stick with that group. Right?
Thank you.
Thank you. Right, so we have the various dates there for the assignments and things. The first assignment is due on the 7th of March. Second assignment, 28th of March. Third assignment is going to be 11th April. And the last one is going to be on the 9th of May. And there are the various weightings of them. We normally have what we call semester work. So in this module, we are not going to have class tests. So therefore then, we are not going to have the SIG test that's coming up is only going to be applicable to the missed assessment, formative assessments, that being actually our class test or semester test 1 and the semester test 2. But please be warned now already that I am not a romantic person, so I'm not going to hold your hand through the course. It is up to you to produce in this course. And therefore, then also there is no such thing as a makeup test in this module. We stick to the agreed assignments. That basically is 4 assignments and 2 semester tests, and that is it. So those who are going to participate in the SIG test, and I see I don't have the SIG test. Yes, I do have it here. The SIG test, this is a mistake here. There is no SIG test at the end of the semester and things. We will see in the study guide, the SIG test is about a week before the predicate, or the Saturday before the predicate and things like that. And therefore, then SIG test will only be for those who have been presenting us with documentation that you couldn't make it for the formal assessments, being semester test 1 and semester test 2. So therefore, then in terms of when you were sick, there is going to be a doctor's note that is needed to be submitted. And what we're going to do, you're not going to send it to me or to everyone things. We're going to create a slot for you to submit your thing online. And what I propose is at least 7 days after we have written the test. So in other words, if you missed semester test 1 by the 22nd of March, your SIG note must have been uploaded onto Brightspace. If you have missed semester test 2, your SIG note must have been submitted already by the 3rd or the 4th of May, and any date later than that, we're just going to disregard. Because, ladies and gentlemen, you need to take accountability for this work of yours. So we are not here to entertain funny things. And that's basically the reason why we do this. So we are going to make sure that the dates and the slots and things are available on Brightspace for you to submit your SIG notes and things. And the reason why we do this is for transparency, so that a person in Polokwane, that me as the subject head can also see that, oh, you did submit your SIG note and things like that. And therefore, then it's not a question about whether I should now trust or mistrust my colleague in Polokwane versus your word and things. So we make it as transparent as possible. Same with Emalahleni. And also, for example, the various lecturers at these various campuses can also see that I am also unbiased in terms of making sure that you are basically given the chances and things that you have, and based on what. So the SIG notes and things will be have to be submitted on Brightspace and things as well, and we will create the necessary slots for that as well. Right. So this is going to be the weights that we are assigning to the various assessments. Your semester test 1 is 30%. Your semester test 2 is 30% as well. And obviously these are now when we work towards predicate. Your semester work, which is the 4 assignments, will contribute 40%. Now, just one thing on the assignments themselves as well. I am going to ask the groups, if you are in a group, it is not up to me as the lecturer to determine whether you contributed or not. It is the word of your group. So one of the pages will be where you sign that you worked as part of the group and things. And if your group feel that you didn't contribute as much as you were supposed to contribute, I take their word and therefore then assign a mark that is being dictated by your group. So in other words, basically, ladies and gentlemen, there is no hiding that's going to happen in the various groups and things are clear. If your group feel that you are not producing, it is up to them to indicate to us as lecturers that you have not produced the clean. And it is not up to us as lecturers to give you then basically a mark and things that you didn't deserve. Clear on that. So then actually when we calculate our predicate, we basically take the various assessments and things actually, and you must have 50%. We know by now of 40% actually for a predicate to qualify for exams, and to pass the module we must have 50%. So that's basically how we look at calculating the marks actually. Right, let's go now into the fun stuff for today. We're looking at introducing you to Java. Now, what is Java? Java is basically a multi-platform and object-oriented language. Multi-platform basically meaning actually that on various devices and things. It's not just on a desktop or a laptop. It can work on a tablet, it can work on a mobile phone, and so forth and things. Now, this Java platform is basically nothing more than a collection of programs that help programmers to develop and run Java programming applications efficiently. It includes basically the following: an execution engine, a compiler, and a set of libraries that are part of a package and things. Now, a compiler basically take your source code that you developed, which is normally written with a specific syntax. It basically then change that into machine executable programs and things which then run. We say it's platform independent, basically meaning the applications run across multiple platforms. And this is a beautiful thing about this, specifically in the world that we're working in now, where you have different types of devices and things. You might have actually a device and things that run on Linux and not necessarily Windows, or you might have actually a device that runs actually on Mac. So therefore, then actually, it is different actually from Windows, or you might have a tablet or a cell phone, and all of these things are therefore then actually used actually, and therefore we say platform independent actually. Just give me 1 minute. There's just somebody at my gate and things, and I don't understand why they're making such a noise. Just give me 1 second. Right, am I audible again? There was just somebody at my gate and things that I had to attend to quickly. Sorry for that, but we are ready to carry on. Where was I? Am I audible, ladies and gentlemen?
Yes, you are.
Okay.
Yes.
Thank you. Right. So we said Java is a platform independent, basically meaning actually that it is not depending on the platform things. Back in the day, in the older before we had such a plethora of platform things, you had to develop something specifically for a Windows environment. Then you had something specifically for a Linux environment. You had something specific for your Mac environment. You had something specific for tablets and things. And now Java gave us this beauty that we don't really worry about the platform actually, and it works basically on all of them. So it is what we call also portability. It's portable across different platforms and things. Now, why do I have that there? Right. So now introduction, basically in terms of data structures and things actually, we say all source code is written in plain text files ending with a .java extension. And I'm sure those of you who have been exposed to Java and things already know about these things. Now, these source files are then compiled into what we call a class file. And we use a Java C compiler that contains all the bytecodes. We know that the class file is similar like an executable file in the Windows environment, the exe file and things. And the bytecodes basically means that our source is basically then converted into what we call binary code, which is machine understandable. We have what we call a Java launcher tool that runs your application as an instance on the Java virtual machine. And there basically in terms of compiling and running a Java program, you have your source code, you have your compiler that compiles it basically into a Java class file, and then at the end of the day, you have a Java file and things that basically runs on any platform and things to create this platform independent structures and ability for your program. So now, in terms of what we're saying, your JVM, your Java virtual machine, is basically is an engine that provides the runtime environment that converts basically your Java bytecode into machine language. So your Java bytecode itself is not necessarily machine understandable, but it is an interim file and things that you have. And your Java virtual machine enables you to convert this Java code or bytecode, Java bytecode into machine language. So we have what we call a JRE, the Java runtime environment, and this basically then is also a piece of software that is designed to run other software, and it contains libraries and loaded classes as well as your Java virtual machine. Your libraries is nothing more than predefined programs and things that we have, and I'm sure you guys are aware of these. And there is just in terms of shows you the how this whole thing works to create your platform independence. You have your bytecode and things, your JRE, and then on the various platforms and things which execute then on the Java virtual machine. Now, since the Java virtual machine is available on many different many different operating systems, the same class file is capable of running on these various platforms that we have. Now, we talk about object-oriented programming. Now, this is basically a computer programming model that organizes files that is designed around data or objects rather than logic and functions. Now, if you look, for example, at a normal structural program, You will have various functions that you call and things like that. But in object-oriented programming, basically, it's a bit different. You've got these objects, and these objects have data, and they have what we call behavior as well. And our programming is basically around the behavior and the data of these objects. And these objects are defined as data fields with unique attributes and behaviors. So the first step in object-oriented programming is to collect all the objects that the programmer wants to manipulate and identify how they relate to one another. Now, we have what we call our class diagram. And our class diagram is normally depict to us how these various objects relate to one another, and sometimes also gives us a bit of insight into how they will behave. And we deduct that from the methods that we have of the various objects and things that we see. So now, in terms of this, object-oriented programming and things is basically based on the following principles that we say. It's encapsulation, it's abstraction, it is polymorphism and inheritance. So since you are advanced diploma students, I'm not going to go into the details of what is encapsulation, what is abstraction, what is polymorphism and what is inheritance and things like that. That is, ladies and gentlemen, some reading that you have to do in terms of understanding this. Now we say that some of the benefits that we have of object-oriented programming is modularity, it is reusability, it is productivity, and it is security as well. I am sure that you guys don't want me to mouth off on all of these things and bore you with all the detail, but you guys can go and read up a bit more on that. So now, when we look at our data structures, and this is basically the majority of the time and things that we're going to focus on in this module, we say and we ask ourselves a question: what is a data structure? It is an arrangement of data in the computer's memory, or sometimes even on the disk, for better efficiency. Or we can say this is a group of or a collection of data elements that provide efficient way of storing and organizing data in with the view that it is being efficiently processed by a computer. Now, examples of this can be arrays, it can be lists, it can be stacks, it can be queues, it can be graphs, it can be trees, it can be hash tables, and so forth. And as we progress in this module, we will delve into more detail in terms of these things. The arrays, what is an array? How does it work? What is a link and how does it work? How is linked lists and so forth and things. And we, over the next weeks that come, we will zoom in far more in detail in terms of how does these various data structures work. Now, there are key operators for these data structures and things. Insertion basically meaning adding to the structure. Deleting basically meaning removing from it. We want to search this. We want to traverse this. We want to sort it, and we want to merge these various data structures that we have. Now, there are sometimes problems that we experience with these data structures, and one of them is how do we handle them in storage, the data storage? How do we handle it? What is the best way for us to store the type of data? Is it scalable? In other words, when it is scalable, can I replicate it over a larger? Can I replicate this over a large population? In other words, can I have one user or 1,000 users? Will my program basically stop working if I have suddenly have 2,000 users? That type of thing that we have. How easy or complex will it be to process and locate the data? At what cost are such processing in terms of this? Because we know that sometimes cost is something that you have to consider as well when you have the various data structures and things that you have to create. Now we are supposed to ask ourselves, what are the programming tools that we use? When we're using the data structures as tools to facilitate some other operations and things. We're talking about modeling. Modeling basically is the need to model or simulate a real world application, scenarios, for example, flights, queuing systems, and all of these type of things that we see in the real world. So now we ask ourselves also why data. We're looking at speed, because in the day and time that we're living in now, speed, processing speed is a very important thing. We know, for example, that when you have any application and the response time is more than 30 seconds, I think you normally lose your audience. And I mean, we have users that are extremely impatient. Look, for example, at you when you're on a website and things and nothing happens. What do? You close it and you move on to something else. So you can easily lose your user if the processing speed is not acceptable. We're talking about data search. The explosion of data and things that we have nowadays and things that we make it in such a way that sometimes the data that we have can be so big that we cannot just go and storm our data in structured ways anyway. You know that in terms of data, you've got two types of data. You've got structured data and unstructured data. Structured data basically meaning anything that you can stick in a database. That is structured data, where you have a relational database and things like various field numbers and things. But unstructured data can sometimes be a problem. And we as IT professionals, in the past used to ignore unstructured data because we can't handle them in our databases and things like that. So we have now in the new world where most of our knowledge and things come from unstructured data. And basically what we have now is that we have what we call data lakes, and then we use data search engines and things like that to extract that, because with unstructured data, you can use some things that are unrelated and connect them to each other by using data searches. We have multiple requests. Multiple requests basically meaning that if you have an application that is running and that has been hosted, multiple requests basically meaning 10 or 15 or maybe sometimes 20 users or more requesting things at the same time and things like that. So now we're also looking at the advantages of our data structures. Efficiency is one of them that we need to look at. Reliability. So efficiency basically means how effective is this thing? Reusability basically means we're living in a world now that you don't need to go and reinvent the wheel every time. Unlike in the past and things when you have linear programming and you always had to define things from top to bottom. With reusability, basically meaning we have components and things, and we can just reuse them. Think, for example, in terms of reusability. Let's look, for example, at Home Affairs. In the past, you had to go and see, for example, if somebody types in a identity number, you had to make sure that this thing is correct. The first 6 characters being the date of birth, the next 4 determines male or female. The next 2 basically meaning it's I think they use it in the past to classify us and according to our various races and things and the last number being a control number. Now what you can do is that you can just refer to Home Affairs and they can verify whether that ID number is a valid ID number or not. And not only that, you can also then with reusability here, you can also look at this ID number, is a person deceased or not? So we see there's benefits in terms of reusability. And abstraction basically meaning that we try and make sure that things are not as complex as we sometimes have them, because sometimes, specifically in our ICT world and things, we like to make things complicated. Now, when you start actually to engage your various users in different platforms and things, sometimes we have to use abstraction, because in that there is simplification that's happening, and we can then basically communicate across a diverse platform, a diverse number of users. So we talk about our application areas of our data structures. It includes our operating systems, our compiler design, artificial intelligence, graphics, as well as simulation. So these are various things that we will see in our data structures. Algorithms, the world works on algorithms, and algorithms is nothing more than a set of rules. Sometimes we call them in the various organizations business rules. So algorithms is nothing more than basically how we take our data structures and build them around various logic, a set of rules. Complexity in things. Sometimes things are just complex. Think, for example, of various simulation programs and things that you have. These things can sometimes be extremely complex. Can you, for example, if you are a systems developer at SpaceX, for example, and these guys need to send something to out in orbit, the various what we call it, what do we call those things again? The boosters, the missiles and things. So we can see it can be very complex things as well. And how do you deal with complexity? So we have what we call also data, abstract data types. These basically tell us, for example, the interfaces and things that we're dealing with here, without the implementation of the details. And for example, how do we handle the various types of data? So now basically in modern programming languages, there's data structures. We have what we call data Java collection frameworks. We've got also what we call a C++, a standard template library. Some other data structures and things that we have. We talk about arrays, and these are the various things that we adapt in terms. We talks about the size of them. We talked about the recreation required, transferring elements from one array to another array. We know, for example, that when we work with data, sometimes we have to create new data sets, and we have to merge some data, and sometimes we have to add new fields or new things into it. So in other words, where we create them, one needs to check if an array is full or whether it's reached a specific threshold before you start adding things. You need to look at entering elements that are in a specific position, and sometimes require some shifting. We need to sometimes remove elements from an array. We need to sometimes search in terms of the array. We need to sometimes make sure that whether it's sorted or unsorted. We need to look, for example, at whether this array that we have affects the type of searches that is used. So in terms of unsorted arrays and things, we sometimes have duplication and things, and how do we deal with that? We have to talk about stacks. Stacks is basically a kind of a list where we have insertions and deletions that can occur in one end, basically sometimes on the top, and this where we talk about our LIFO structure, last in first out structure. In other words, the latest addition and things will be the first one that you will lift from your stack. We directly have various functions and things that we will add to our functions. Pop, for example, is basically where you add something. Push is where you remove something from a stack. So these are basically some of the data the basic terms and things that we will have in our data structures. What is data? It's an elementary value or a set of values. That's data. A group item is basically data items that are related somehow with one another. An attribute is basically an attribute represent one particular property of an entity. For example, if you look at student number would be an attribute. Gender would be an attribute. The module that you're taking would be an attribute. The course that you're taking would be an attribute. The mark that you get for a specific assessment will be an attribute. Your final mark that you have actually will be an attribute. Your final determination, whether you pass or fail, a result will be an attribute actually. So these are the various things that we talk about. An entity is basically a one representation of a class of a certain object. Say, for example, an entity would be, for example, if I look at a student, for example, student can represent one, or it can represent a whole class full of students, and they all have the same attributes. Fields are nothing more than a single value that I have in front of me. A record is basically what normally say is a collection of various items that and each record contains the data entities. For example, record can be, for example, once again, if I look at a class and I look at the class student. So, for example, I go walk into a lecture room. This one, for example, that we have right now. We have about 121 people in this class of this morning. So in other words, we've got 121 records because each and every individual is a record. And each and every record actually have various data items. Each and every one of us has got a name. Each and every one of us got an age. Each and every one of us has got a gender. Each and every one of us actually is either you're a student or you are a lecturer, and so forth and things. And a file then actually is nothing more than a collection of the various records. So if I, for example, look at today, the class of today, so that will be a file, and everybody that is actually in this module right now will be records. The 122 that we have right now will be records in the file, and the file being the event that happened today, this specific class, at the duration that we had from 8:30 to whatever time and things that we have. Right. So we've got linear and non-linear data structures and things actually. And there's a write-up on them. You've got your primitive data structures and you've got your non-primitive data structures. Linear versus non-linearly. Static basically means it's an array. Nothing changes about it. It remains the same. Dynamic basically means it's changed all the time actually. And there you will have your limited lists, your linked lists, you will have your stacks, and you will have your queues actually. Your non-linear basically meaning a tree or a graph technically. So these are basically in terms of our structures. Your linear data structures basically mean something like this. You will have an array with and an array is nothing more than a group of values that are from the same data type. Lists are a sequence of 0 to more elements of a given type. Okay? Now, typically, your list can represent an array. It can represent pointers. There are also what we call double linked lists. Traditional lists and single lists. Double linked lists are normally what we call circular. In other words, it will have a beginning and it will then point to the next one and so forth. We will have what we call the linked lists. These are normally linear structures that maintain a list of memories, and it's normally sorted in a specific way. Normally we have what we call nodes. As my example, I will have normally a head, and it's basically nothing more than the beginning of it. I will have my data and a pointer to the next one. And so until I reach a point where I have a null, and that basically means it's the end of that specific list. So here we have a stack. Stack is basically nothing more than a special kind of list with insertions and deletions that occur at one end. So in other words, with a stack and things, if I, for example, have my LIFO structure, last in, first out, basically meaning here on the right hand side, I have my stack. So in other words, when I do some insertions, for example, here my pop, I will basically look at where was my last insertion, which was at my index number 3, and then if I have to add another one, it will be at my index number 4, basically, because that's going to be the space and things where it is empty. So in other words, I need to make sure also before I add something, is it empty? Yeah? And the reason why I want to make sure it's empty, I don't want to lose a value, because we know that a stack almost behaves sometimes also like a variable. It will only have one value there. So therefore, then I don't want to override that value. That's why I want to make sure that it is empty. Or if I want to remove a value, I want to make sure that I make it empty. Queues are basically nothing more than a special kind of list in which all items and things are inserted. At one end is either at the rear end, or the back, or the tail. And the deletions can either be at the front, in other words, the starting point, or at the head. Starting point, front, and the head is basically nothing more than the same thing. And here we're using FIFO, first in, first out. And we will also have various functions like NQ, DQ, NQ and things, DQ and things. These are things as we progress in the module and things, we will give you more details on that. We can implement pointers, and we can also implement a circular way of using an array or listed links. Here, for example, in Java, for example, we will definitely use the library stack. And luckily with Java, these things are already predefined libraries, and we just import them, and then we can use the methods that are available for us with functions like pop, push, seek, size, empty, and so forth. So we don't need to go and define those things. They are defined for us already, and that's the beauty that we see here with reusable code. So now in terms of we look at data structures, we sometimes refer to them as sequences also. It's basically a sequence of 0 or more elements of a given type. They are typically represented in an array, but they can also be represented using pointers. And pointers and things we will see later on that it's a special type. Now, in terms of these data structures, we can add or insert, we can delete or remove, we can search, find, or look up, we can replace or reassign, we can merge, we can sort. So those are the type of things that we can do with data structures, with a list data structure. And the type of list and things that we have, it is either array or array-based or traditional lists. It can be a single list, or it can be a double list, it can be a circular list, and so forth. If we look, for example, at our list structures, we can have either a sorted or unsorted, or ordered or unordered one. We can also have a list data structures that allows repetition of elements. In other words, basically one specific value that can be repeated more than one time, and it's not specifically limited to unique values. Array stores only homogeneous data. In other words, what we're saying with homogeneous data and things, it is only one specific type. So, for example, if you have an array with, let's say, for example, student numbers, we know it can only be a numerical value and things that we have there. However, a list can have what we call heterogeneous data items. In other words, I can have different types of data in my in a list. I can have the one value can be a student number. The next value can be, for example, something like a birth date. The next one can be something different. And we see that there is no homogeneity in terms of the data. In other words, they are not all the same. They are different. We see, for example, there actually are examples of this. List 1 and list 2. List 1 basically meaning homogeneous is the same. Heterogeneous is basically different ones. So we say also a list that is basically nothing more than an array-based implementation, and normally it's dynamic in size. In other words, what we're saying here that we sometimes will have 10 or 100, 5, and so forth. So the size of our array basically varies, and it's not necessarily static. In other words, it doesn't have a specific beginning and a specific end. It varies in size. So when we look at Java, this is basically how we implement our list. We will have various libraries and things that we will include. This specific one is a predefined library. These are predefined libraries and things that we will include because that gives us the ability to use those classes and things that we have identified, and we can generally just refer to them in our program. For example, here we use the method add, and we just add our data to the list and things, and without having to worry about what does it mean, because these things are already defined for us. So we see that with the predefined functions that we have in our lists are add data, print data, update data, and remove data. So once we have these things, because they are defined already, we can just use them. And here is basically the Java code in terms of how do we use these various functions. Basically, our linked lists is basically a data structure that is maintained in a list in memory and is storing nodes of non-contiguous memory allocation. In other words, basically what we have here is that we will have various spaces in memory and things, and we will have a pointer and things that points us to this value is at this point. The next value is at a different point and things. So right, we have the various types of links. We've got singly linked, we've got doubly linked, and circular linked lists. So singly links are basically two field nodes. In other words, two field node basically meaning that the last pointer is normally a null value. We will have basically a starting point, we have the data, and then also the pointer to where is the next address. And it also to give us a ability to navigate the list actually, and it's normally in one way only that we can do that actually. So we must have a starting point actually, and the starting point will actually give us actually then the ability to move to the next one and so forth. Doubly link basically means actually that we can go into both directions. So singly basically means this one direction. Doubly basically means it is both directions. So we will have a starting point. We will have the previous. We will have the previous pointer. We will have the data, and we will have the next. So in other words, it gives us then the ability. For example, if I have to go and move backwards and things, I will use the previous pointer things to give me the ability to move from the end to the front. In other words, it gives me the ability to do bi-directional. If I need to move quickly from front to back and things, I will then actually use the next value and things to determine actually where is the next data actually, and where is the point for that actually. When you talk about circular basically you have a starting point actually, and it's also a two-field node. I think you've got a starting point actually, and it's almost like on a circle and things. It traversally in almost like a similar way as your singly list and things actually. But here your end is not a null value. Where your end basically will point you back to the starting point of your link. Queues, we have queues basically is basically a special kind of link with inserted value at one end, and it's called either at the rear or the back or at the tail. In other words, where you will have your null value. Here it also use your FIFO structure. FIFO, so first in, first out. In other words, it removes things from the rear end or from the top. That's basically what it happens in terms of queues. It will remove it from the top because you normally start from the top. When you dequeue things, you remove things. When you enqueue things, you add things. You will also have peek basically means where you have to go and look into it when you search for things. Is full basically gives you the ability to determine whether there's a stack overflow. Is empty basically means an underflow. In other words, with an underflow, it cannot loop through it because there's nothing in your stack. The types of queues and things that we would have, you will normally have a beginning point. The front end, you will have your first value, second value, third value, and so forth and things as well. This is normally the most common one actually. And the insertions only happen from the back because remember we're using a FIFO, LIFO, last in, first out value here. When you talk about our circular queue, once again, it's almost similar like a ring buffer where you will have last node is normally at the back. And this you normally overcome the challenges of single lists and being able to insert new elements at the back of the queue. So it is better. This is normally used we use this for better memory utilization. And also we normally have this element when we want to increase the queue size. We have what we call priority queues and things, and these are normally elements that is based on priority. So typically, for example, you will basically use a pointer and things determine where is the highest value and things like that. Your insertion is normally based on arrival. Your deletion basically based on priority. In other words, LIFO and FIFO will be FIFO will be the principle and things that you will use here in terms of this. So there we have then what we call our priority queues. And these are normally priority queues in terms of ascending order or descending order. And normally when we start with our ascending is nominally the insertion arbitration. This is basically where we basically from small to big, small to large, ascending, it increases in value. Decreasing is descending is normally just opposite, from high to low. We then actually have what we call our double-ended queues, and this is normally what we call DQ. The insertion and deletion is done actually on both ends, from top and from the bottom as well. We use this actually normally in a stack as well as in a queue, and it does not follow the FIFO principle. FIFO being basically meaning first in, first out. Right. Some other data structures and things that we actually, we talk about our arrays. Our arrays basically is a fixed size of it, and this is normally done at creation when you define your data types, your data structure. You define it actually, and it creates this actually. And we know, for example, that when you have defined it, it cannot change. It remains the same. The values and things that are in an array are of the same type. Now, when we say that we're creating, when you are recreating this, it requires the transfer of your elements from one array over to a new array. One need to check if the array is full or if it reaches a specific threshold before adding new elements to it. In other words, when you have defined your array, you need to, for example, to look at out of range problem and things that you will normally have with your arrays and things, and make sure that doesn't happen. Entering basically means that the entering elements at a specific position may require shifting others. Say, for example, if you've got values that are increasing, ascending values and things like that, you need to, for example, to shift things up. If you, for example, have 1 to 10 and you add the numbers randomly, you need to always make sure that they are shifted in such a way that you present the phenomena of increasing values. Deletion, for example, also this is just another one where you basically have to also start shifting things around when you remove something from array, because you don't want to have null values in the middle of your array and things, and that's why the reason why we searching basically where you, for example, go and look at specific values in a list or in an array and things Sometimes you want to have them sorted or unsorted. Sometimes when it is sorted, it affects a specific it might not affect certain types of search methods that is used. Unsorted arrays can, as we say, sometimes create the problem for you that you will have duplications in your array. So these are what we call the characteristics of data structures. We've got an array. There's the advantages and disadvantages of it. An array, quick insertion, very fast to check if the index is known. The disadvantages of this is it's slow to search. It's sometimes slow to delete, and because it's a fixed size and things also, that can be a limitation to it as well. So I'm just going to use random ones here. For example, a queue. It will use the FIFO access, but also the disadvantage of it will be, for example, slow access to other items and things. Like, for example, we have what we call trees. There are different types of trees. We've got binary trees, red, black trees, and 2, 3, 4 trees. The advantages of binary trees basically is quick search, insertions is quick, deletions even with deletions, the tree will remain balanced. The disadvantage of binary trees, for example, will be the deletion algorithm is very complex. You will have actually hash tables, you will have graphs and things as well. And for example, the advantage of graphs actually will be its real world simulations. Actually. For example, you can use in an election, for example, a graph actually where you will use various say for example, various wards actually. There, for example, you can then actually maybe use actually the values or the characteristics of various wards and things actually in a graph actually. But sometimes actually also actually the disadvantage of graphs actually are basically that some algorithms are slow and very complex. For example, I mean, look at a graph example. If you have to increase or insert things actually into a graph and things, it can be quite a bit of work. Now, when you talk about complexity is nothing more than the classification of algorithms based on the relative amount of time and space it requires and to specify the growth of time and space requirements as a function of the input. Growth of time basically mean, or the space requirements specifically, growth of space specifically, for example, in a time and things where we know there's such an explosion of data all the time and things at the end, this can become a problem in things in the sense that your data can grow at exponential rates. And one of the reasons why it will grow at exponential rates is because we know that data storage is cheap. Talk about the types of complexity, time complexity, basically meaning here, running a program is a particle of a function and the size of the input. And we know, for example, in a time and things we're living in where we want to have instant results, time complexity can become a problem where you have to have specific time responses to use user requests. Space complexity basically means that the amount of memory that is required actually, and I mean with sometimes the volumes of data and things that we have actually, it can really become a problem. So basically, there are different ways of representing complexity. One of them actually is worst case running time. This is basically where we look, for example, at if things are going wrong. Average case running time and things. This is normally where we use a random drawn random from a given distribution. Say, for example, I want to look at over a period and things. What is the average time, running time and things for that? And amorized time. This is basically an example where I will actually have a perform a sequence of operations, and it's basically averaged over time and things as well. There we have then basically our big O, big omega, and the big theta notations. These are ways and things that we will have actually our complexity notations actually. So a convenient way to describe the growth rate of a function or and hence the time complexity of this algorithmically that we have there. So we normally look, for example, at the input. We will then have actually the functions, the positive functions of n. We will then actually have a definition actually that if the sum of the function of n is also the let me just get my bearings straight here on this one. Sounds like somebody want to help me there. What happened to my thing now? Ladies and gentlemen, I think on this one, I need to read up a bit on it actually, because I might tell lies here. On the big O notation. So I think I will have to come back on that one. When we look at putting complexity into perspective and things, we normally have actually the various scenarios and things we will have our worst case. In terms of quick sort, we will have our worst case versus our average case. In terms of our merge sort and our heap sort, we will also have our worst case versus our average case. Bubble sort, the same thing. And we basically plot this over a time and iterations and things as well. And that will give us basically the view of it will basically give us a graph in terms of where we start comparing these various these four types of sorts with one another, and then based on that determine which one will be the most efficient one for us. So ladies and gentlemen, I think I've spoke a lot in terms of what we've dealt with today. Any questions? Yes, sir.
Can you hear me?
I can hear you, yes.
Yeah, I just wanted to know, are you going to share the slides you are reading with us?
Yes.
Okay.
After this, I will both actually have the slides up onto the on Brightspace as well as the recording.
All right. No, thanks a lot.
Okay.
Hello, sir. I have a question here.
Yes, sir.
Yes. On the textbook and the slides, I'm not sure if you can highlight what chapters we are going to do on the book, because on the not a slide, I mean a study guide. On the study guide, you see there are topics which say A1, B1, but on the textbook, I think they are mixed up. Can you please show us where they are? Thank you.
Okay, I will have to look at it. So what we will normally do in this module is I might not go through each and everything there that's in the study guide. I will highlight certain things, and the views at the end of the day that I will focus on most important things. Today's lesson, for example, was just an introduction. From next week, we will be able to pinpoint exactly where we are in the textbook and what it is that we're focusing on. So today was just to lay the lay of the land. Let me share I'm just going to share the study guide with you to show you what I'm talking about. You will see, for example, today. Let's just move up a bit. It was just a basic introduction. What we, this is just to start knowing each other and so forth and things. But the various learning outcomes and things from next week onwards, we will specifically focus on them. So, for example, A1 and A2, we will delve into detail with that next week. B1, B2, and B3 will be focused on next week as well, in more detail and so forth. Does it answer your question?
Yes, it does answer my question. Yes, yes,
Okay.
yes.
Okay. Next.
So how are you?
Well, and you?
I'm good. I wanted to ask about the exam because on the assignment you said you can use any language, but on the exam, is it a must that we use Java?
We prefer Java basically for the reasons actually that at the lab where you are going to write, we will not have access to the internet, for example. We normally, I think we will make sure that Java is enabled in the labs and things like that for you to be able to participate in the exam. We will not be able to ensure that your C++ and Python, we're not sure about that. But in terms of Java, we will make sure that that is available in the labs.
Okay, because I saw on the IDE you suggested NetBeans and Visual Studio, and on Visual Studio we have C++ pre-installed.
Okay. Point taken. Although we have actually C++ as part of Visual Studio, I think it's up to you. Is my colleagues on this? You see, my colleagues can maybe help me here also, because it seems to me that the question that the gentleman have, he's got a specific preference.
Yes. Good morning, Pelotang, and good morning, ladies and gentlemen. Yes. We said that in terms of illustrating these examples in class, we may use Java most of the time. But when you write, we said, I mean, you have got a choice. I mean, whether you use Python, C++, or Java. So it's up to you in terms of the test and also in the exam. But what we're saying is, in terms of presenting the lessons, because I mean, it will take a long time to show this example in Java, in Python, and also in C++. Thank you.
Okay. Just note, sometimes one of the problems you might have with Python is many people use Colab, Google Colab and things like that, and that will require you to have access to the internet. So if you're going the Python route and things, you might run into problems in the scenario of an exam or semester test and things as well.
Okay, so I understand, but I also understand that the packages in Java, they use the JVM, and in Python, we also have its own tool. We can also use it offline, where we have the Python editor, text editor, which can be installed the same way as Java, rather than depending on the internet. Maybe the issue would be on the packages when we need more packages.
I hear you, and I mean, there, for example, we actually would want to maybe as lecturers ensure that you have a fully functional Java environment and maybe a C++ environment. We cannot guarantee in terms of Python.
Okay, no problem. I understand that.
Okay.
Makes sense.
Okay. Any more questions?
Yes, sir. No, I don't know if it'll be fair of me to ask this kind of a question, but I hope maybe to get a respond. Well, I think from the module name itself, maybe it can be self-explanatory that we working with data structures and algorithms. But then I would like to get like a more I don't know, personal explanation from you with regards to what mainly is the objective of this module and how it actually gonna maybe help us, and something maybe that by the end of this course or by the end of this module you should be able to be achieving. Yes, I think that's my question.
Mm-hmm. So the aim of this course is to introduce you to the fundamental concepts of data structures and algorithms. And we will sometimes include at least some programming environments there in terms of the study guide where we have the introduction. We clarify that. Does it answer your question?
Oh, so it's mainly just the getting to understand like the fundamental concepts of data structures and algorithms.
Yes. So if you
I think maybe
Hmm?
okay,
Carry on, sir.
maybe let's add. I mean, remember the whole idea of software development is that you have to be able to use all the necessary tools to efficiently write your programs. And this particular course, I mean, that we're doing at TUT in data structures, is to say there's a better way to represent your problem in terms of software. And then we want to expose you to the different data structures to say, I mean, if you are dealing with a particular problem, this may be the appropriate data structure to actually use. And remember, Mr. Lotseng has talked about that. It's a question of how we represent the real world in software development. So, and I mean, you, as a software developer, you have to make sure that you select the appropriate way to represent whatever you are doing in terms of software. So the whole purpose is to say there are different ways of representation in terms of what we refer to as the data structures, and which will be the best one to choose for your situation. And that's why, for example, you'll see in the test and even in the exam, we may give you a problem and ask you, if for this kind of a problem, which data structure do you think is appropriate, and why do you think is appropriate? And then we can go on to how you actually apply it in terms of the programming language that we're actually using. Thank you. Does that answer your question?
Yes, I think that was satisfying. Thank you.
Okay. Any more questions? Thank you, sir, for helping out. Any more questions, ladies and gentlemen? You can go ahead and ask your question. Sibanyoni, you can.
Yes. Sorry, sir. Good morning.
Morning.
I'm looking at the last slide that you presented, the putting complexity into perspective, right? And there's something that I see that is common between the quick sort and the merge sort on the average cases.
Let me just get back there. Do I go back?
Yes, there.
Yeah, okay.
Why is the merge sort preferred over the quick sort in some cases, despite both having the O and log n complexity?
Yeah, you're asking me a deep question here. I think, can I maybe let the prof actually help us here? Because I think I was just laying the foundation. We are still going to delve into far more details with us.
Mr. Dinarova is here. He will answer that one.
Okay.
Yes. So sorry. Could you please repeat the question? Were you asking about quick sort and merge sort? What are you saying about it?
I was asking what is the difference usage of the quick sort and the merge sort, because they both have the same equation for the average case, which is the n log n, the O n log n.
So if you look at the average case, right? So it tells you that on average they perform similar, but on the worst case, that's where they are different. So what makes them different is how the data they receive makes them perform differently, right? So what this is saying is that on a worst case, it's better you go with merge sort than a quick sort, right? So but on average case, they do not, like, they perform similarly. you can apply either quicksort or merge sort. But big O notation tells you mathematically, if you were to give these two algorithms data, let's say with billion items or million items, which is n there, which is what n stands for then. There, it tells you which one will perform better, either in terms of memory efficiency or space or time efficiency, right? So that's how we measure the complexity. So you can either measure in terms of how fast it gives you an output, or the amount of memory it uses to give you an output. So what this tells you is that, you know, if you have a collection of things to sort, on a worst case scenario, it's better you go with merge sort, because n log n, it in fact in a way you know, performs better than the order of n square. Does it answer your question?
Yeah, I think I'm sorted.
Yeah, so it just saying that quick sort and merge sort on average case, they are indifferent. You can choose either. You can choose either of those two, and but when it comes to worst case performance, that's where they, you know, those two algorithms are different.
So basically, the merge sort is reliable because it always gives you the on log n in all cases that you work with.
It's
Am I getting
quicker.
it right?
It's quicker. Not
Okay.
not in all cases. In worst case scenario, merge
Scenarios,
sort.
yeah.
Yeah.
Okay. Cool.
So
Thank you.
both of them are complete, right? So what this tells you is that both of them are complete. They'll give you an answer at the end, but their performance are different. Their performance in terms of speed, it's different.
All right.
Okay, I think there was another hand for you, Mr. Lutheran.
Okay, I'm listening.
Morning, sir. So,
Morning.
sir, after the explanation that was received, can we conclude in saying that binary search trees perform better than the other provided algorithms, seeing that the worst case is better than all the worst cases that were provided there, and the average case?
Definitely. If you look there, the worst case for binary search, you know, in fact, it's, let me say, it's linear compared to other worst case scenario, which is the other one are quadratic. Most of those are quadratic, but for the merge sort is n log n, right? So this graph on the left shows you that if you were to give binary search very large input, it will perform better, right? So Tn is your measure. It's your measure of performance. Maybe that's how long it takes for the algorithm to give you an answer. So what it tells you is that binary search will give you an answer quicker than all of these algorithms that you see above the binary search tree. So binary search tree in a way is efficient in terms of searching, search performance compared to the other algorithms. Is it a follow-up question?
Yes, just a minor follow-up. So does this mean throughout the semester we'll be focusing on the most efficient rather than heaps, hash tables, and others?
So remember, you need to understand if something is efficient, right? We will not only focus on the efficient ones and forget about those that are performing poorly. We need to understand the spectrum. You need to understand why would you say the other algorithm is performing better than the other. You need to have an explanation. so that when you sit in your software engineering job, maybe with Amazon or Facebook, they ask you, okay, why did you choose to use hash maps? Well, you need to be able to explain it that, okay, hash maps is efficient in terms of performance. Yeah. So we'll not only to simply answer this, that we'll not only be focusing on the nice ones, the better performing ones, but we'll also look at generally look at the whole spectrum. That okay, maybe in the 1970s this is a set of algorithms that which were used, which were preferred, but the state of the art now, what is used out there is this set of algorithm, and what is the difference. So you need to develop your reasoning ability in your choice of data structures.
Sir, maybe if I can also add, so I'm a student, but I've had some experience with some of these things. So
yeah.
So so you learn all these, let's say, algorithms, sorting, all that. Some are quicker than others, yes.
Yeah.
But what the other thing the student must also understand, especially in real life, is how easy is it to implement some of these things, right?
Yeah.
And why would you want to do that?
Yeah.
So yes, a quick sort is n squared, and the binary is n.
Yeah.
But there are some situations where the trade-off to implement, you'd rather go with the quick sort because the problem you're dealing with is very small.
Yeah.
And the gain of using a binary, the time it takes to develop the binary search for that problem is long.
Yeah.
Whereas the quick sort might be shorter. So in industry, and that's why if you work at Facebook, whatever, that's why they would ask you, why would you use this in this scenario?
Yeah.
And so you must give the answer. So you learn all these things so that you know what they are. And when you have a problem, you must choose which one.
Yeah. No, that's one point.
Yeah, Mr.
Yes.
General, can I just make a very quick comment?
Yes,
you know what? The gentleman who just gave input now, that is very good. One of the things that we were discussing before this class is we also want to leverage on the experience of everybody who works with these things on a daily basis. And because we are at postgraduate level, your expectation, it should not be like an undergraduate student where only the lecturer knows the correct answer or the best answer. So we are inviting everybody in this class to be a full participant. I mean, not only to ask questions, but also to contribute to the answers and to the solutions. And what the gentleman has just done now, I mean, it's what we want, and we want to encourage that. I mean, if there are other people in this class, if you want to contribute to this particular discussion, we actually want you to do that. That's what we want. I mean, at this level, it's not to say, okay, the teacher has spoken and that's the end of it.
Yeah.
We want to commend the gentleman and want to encourage others, weigh in, give your opinion, give your experience, and so on. All right.
Yeah.
Thank
you. Yeah. I think also there's, our having that prof makes our module more relevant. That what you are teaching is not something that is far-fetched, but it's something that student will be able to use in their workplace. So yeah, no, thanks, Prof. Over to you, Mr. Lottering, if all the questions are answered.
Thank you, ladies and gentlemen. I think all our questions has been answered now. Any more questions? Yes, sir.
Thank you, sir. One last argument, seeing that we are on this item. Now, I fully take into account that the way of the trade-off that the gentleman just put forth to say to resolve a challenge, the quick sort might be more appropriate. But then would we also not say that is why we find solutions that are more or less built in-house. Let's, like, for instance, systems that are built for registration of students within the different government departments, where we find them crashing after there's high volumes of people on the system itself, because the N within the worst case, it is when the input is actually higher, and when it's squared, then it becomes exponentially troublesome. Vis-a-vis when you already know that the what you're building, its worst case scenario would not be squared, because we know anything that goes squared can go into high proportions of challenges. So putting into account that, yes, we are looking at what to use, but what you might want to use now when you're building it versus when it is actually being used. That's where we actually get into issues of high volumes accessing it and the system not being able to respond.
But don't you anticipate, for example, that you will have high volumes and things as well during the time and things when you develop your systems and things? Because remember, one of the things that you need to look at is scalability.
So having put that into account, you're also taking that this is complexity, how complex the algorithm is. So yes, quicksort might be easy in implementation and it might get you the necessary results, but we are trading off worst cases over average cases. So whatever that you're building, usually when we test it averagely. So we test it on average case, but when it hits a stumbling block, being worst case. That's why my argument was that should we not be working on a binary search tree, because you already know that its worst case scenario can be handled, rather than hitting a worst case scenario of ON squared.
Yeah. So, but sorry, can I please jump in, Mr. Lotrin?
No problem, sir. Carry on.
Oh yeah, I just wanted to say that when the students say, why don't you just focus on maybe average cases, that not all problems will present itself in an average case, right? Some of them will present themselves as best cases, some will present themselves as worst cases. So you will not want to use one algorithm to solve all. So that's what this course will teach you. So this module will teach you that when you have a problem, in terms of your choices of algorithms as an engineer, how do you make best choices for problems? So that's what you'll be evaluated on, that are you able to make best choices with understanding when solving problems?
Does it answer you, sir?
Much appreciated. Thanks.
Thank you. Is there another question there coming?
Oh, I don't mean also to drag the discussion, but is it possible to maybe have them use them interchangeably, like based on maybe even with the same maybe data set, if maybe that's the case, whereby like we have the same data, but then be able to like use it interchangeably, like maybe if there's a need for a quick sort, then we make use of it, and if in the very same maybe data set, then now we see a need for a binary search tree, can we do that? Is it possible, or we only got to make that choice maybe whenever we are solving that specific problem and can't dynamically get to change it?
I would suggest actually that the latter, actually, because you don't want to, like my colleague said, you don't want to generalize a specific problem. Need to have a specific response, and if you start generalizing and things, actually, you might lose. And I mean, what we want to teach you in the modules is how do you respond to specific problems.
So what would you consider it be maybe generalizing
A blanket approach. You cannot have a blanket approach to all the problems. I know it's the easiest way of solving a problem and things like that, but we want to teach you specifics.
Thank you.
Thank you. Any more questions?
So when do you calculate the time and space complexity? Is it before or after a code is developed?
What do you think? What do you think?
I think it's after a code is developed.
Yes, because you have to develop the code and then you test it. But I mean, obviously now with experience, because you would have tested several codes, you will actually be able to have a good idea. This code that I'm developing, the probability is that it may be this big O(n). But I mean, the test of the testing of the pudding is in the pudding itself. Thank you.
Thanks.
Okay, ladies and gentlemen, any more questions? You can go ahead, Pete.
Morning. Okay, I hope you can all hear me. Morning, sir.
Morning.
Yeah, I know maybe my question might be not really relevant to all the questions that that have been asked in terms of these binary trees. So my question is that across these important topics like this, for example, let's say development of this binary search or bubble sorting, will we get like something like, or will you upload like practice examples on D2L? Actually, what I mean, will we be provided with like some guidance of previous previous question papers and solutions in D2L in this module? Maybe if I'm straightforward.
I think I don't want to preempt the approach actually that my colleagues and things are going to take also, but obviously when we deal with the topics and things, we will deal with the topics in detail, showing you, for example, also clear how to solve the problem. And I think within that, you will be able to get exposure to it.
Can I add, Mr. Lutri?
Yes, sir. You make.
Yeah. So previously, how it's been done, it's that you'll be exposed to this algorithm. So if you go on the internet, you'll find full implementation of these algorithms, right? So everything is out there. So what in this class we'll do is that we'll pull those resources, pull the resources out there, the code and everything, and then we say, okay, this is how this thing has been implemented, right? So then it will be explained to you. It will be explained to you that, okay, quicksort. So how is quicksort implemented differently that makes it to have a worst case performance different from match sort? It's this particular set of code, right? So, and how they've used the data structure, this is how it looks like. And then we analyze it. We take an example, we run it, analyze it, and then it would be shared with you, right? So in a way, we are not going to try to reinvent the wheel. We're not going to try to say, okay, we will code bubble sort from scratch. No, people has already been doing that. So what we will do, but I don't think we'll get to implementing all of these algorithms. So what Mr. Lutring said is that we will dive deep into the data structure, let's say a stack, and then we ask you, okay, how can you use stack to solve this problem? And then you need to explain that, okay, stack works like this. Will it work? Will it be a best algorithm for this problem or not? Right. So so in the algorithm that we'll be talking about, you'll get full implementation of that, and we'll be sharing that with you on my Twitter. So, and then from there, you take that in, you study how it works exactly, and we'll discuss it in class, like in next week. As I'm planning, our lecturing session, I will be going through implementation, right? So, awesome linear data structures. And from there it will be shared with you, made available to you, and then when you prepare for your test and your exam, then you'll be told, okay, this, you remember in class we discussed these algorithms. Okay, maybe you may be given a code, an incomplete code, and then you are asked, okay, complete this section. Right. So how you know, or how you have learned how stack works, complete this section, make sure that you solve this problem. Thank you.
So what we're saying basically is that you will be led by the question in terms of when we assess this. Right, ladies and gentlemen, any more questions? I think this is quite a lively session today. And I like it actually that people ask questions and things. Questions are not there actually to show what you know and what you don't know. Actually, it helps to clarify things.
Yeah, and we will welcome more participation from everybody. I think that's very important. Thank you.
Okay, ladies and gentlemen, if there is no more questions and things, I'm going to stop sharing. And then I'm going to stop the recording as well. And then we'll make this available as soon as everything has been saved and downloaded. I think I will make it available on Brightspace for you as well. So with that being said and things, I think we can adjourn.
Thank you.
Bye-bye.